Okay, thank you. Now we have been talking about how to become fast, and the next step will be safe. I talk about safety. Personal safety, not track safety. Your safety. Take this. And I work with different teams in all over Europe, or all over the world actually. WRC teams, GT3 teams, drag racing, drifting, all kinds of motorsports. What they have in common is that they use a helmet and they use seat belts. That's very important to understand, that we talk about safety in regards of using seat belts and seats. We also have, go-kart and different kinds of motorsport where you don't use seat belts, and that is, it's very difficult to be safe when you don't use seat belts, or it's difficult to have control over the energies in a crash. This is a film from Brno, and it's a NASCAR crash. Here you can see that Lamborghini crashes, and the guy is actually thrown out of the car when it's burning. You see him, he's hanging out of the door there. The seat belts are loose. He's out of the car. This is NASCAR, 300 kilometers per hour. He crashes into the wall, and he just jumps out of the car after the crash. The reason I'm showing these two short films is so you understand that it is not about the speed or the type of crash. It's actually about how you use your safety equipment. If you don't use it correct, and you have very expensive safety equipment, you will still get hurt. It's very important that we use equipment in the correct way. And how do we learn to use the equipment? This is how we do testing. This is a film that shows a Hans device on the dummy, test dummy. And the guy survives, of course. We started testing with the apes. It was together with NASA in America, and in the beginning the apes were killed. And the reason for that was because we strapped them at the laps and the chest and the head at the same time, and then when it was a crash, everything stopped at the same time, which meant the brain continued and was crashed inside the skull. And this is how we do today. We have, first of all, move over here. First of all, we remove the energy in the lap area, then the chest, and finally the head. So we have 1, 2, 3 step process when we remove energy in a crash. That is very important to understand. And this is how it looks when you crash without the Hans device. And as you can see, everything we do when we test, we do it with 100% correct harness geometry. The seat belts are installed exactly as we design them, we install them, and we test them. If you install your seat belts incorrect in your car, you will not survive, even if you have a Hans device or a hybrid device. It's very important to do it in a correct way. This crash was in 70 kilometers per hour. The energy in 70 kilometers per hour is enough to break your neck. Think about that. Most of you go in speeds that are way higher than 70 kilometers per hour. But you should also remember that the speed and the energy I talk about is a dead stop. And when you have a dead stop in 70 kilometers, it's enough to crash, to kill you. But if you have an offset crash like that, you might need to travel in 150 kilometers per hour to break your neck. This is the most common crash, side crash or offset crash. And I think it's very important that you see how much you move in a seat when you crash. If that guy had been wearing an open face helmet, he would have destroyed his face, the breathing, the teeth and everything. That's the reason we use full face helmets in closed cars. That's to protect the face. We have a Formula 1 boat driver that we are working with, and he crashed and broke the front window in the car, in the boat. So all the water was coming in the cockpit. And he actually the helmet broke in the front part. He was using a full face helmet, but he survived. And the part that broke apart from the helmet, it moved against his mouth like this and actually protected him from drowning. So it's a good reason to use full face helmets. Always do that if you can. This film shows a co-driver with a Hans device and a driver without. The driver is unconscious, and then he wakes up, and then he's unconscious again. It's from Sweden. I posted this film 2 years ago, and I think we had 2 million views so far. And I think it's an excellent example that shows used equipment that are around. Even if it doesn't say in the rule books that you must use a Hans or a certain equipment, try to use as good equipment as possible and install it correct. And it doesn't matter if we have carbon helmets or we have 6, 7, 8 or 9-point seat belts. We still have a lot of accidents. We actually have, last year I think we had 34 people killed in motorsport accidents in Europe and North America. And that means counted people. Some of the countries, they don't report when people are killed in motorsport. 4 or 5 years ago we were 12, 13, 14 people killed, but it's racing. More people are getting killed in motorsport accidents. And here you can see the problem areas. It's of course rallying. Rallying is really difficult because we have the roads, we have trees, we have rocks, we have spectators. We also have road circuits and drag racing. A lot of bad accidents. The only areas where we see improvements is the areas where FIA have been putting in a lot of money. That's in Formula 1 and in NASCAR. It's very protected environment. We have very good walls that take up energy. We have, in Formula 1, we only have 25 drivers in the world, so we can actually control them and teach them and learn everyone how to behave. The problem is you. Because you do it because you think it's just fun, it's for fun, it's a hobby, and you do it because you're passionate, you like it. But usually when you have fun, you don't think about the dangerous part. And I can promise you it's really dangerous to do motorsport. And the danger comes when we do what we just been taught, how to make the car faster. And when you have a competitive mind, you always try to go faster and faster, and you search for the limit. And it's actually when you find the limit, you crash. So the fastest guys, they usually crash. Think about that. This is the problem areas. Seatbelt geometry. The geometry of the seatbelt, how it's installed in relation to your body, that's what it's all about. It's the seat and the seat belt that is the most important parts of the safety in the car, or to keep you safe. Of course, a roll cage is also important, but this combination is priority number 1. We also see very often that people install seat belts, it looks good, but they don't anchor them correct. Yet they have one of the lap belts over here, high, and the other lap belt over here, low and short. That means in a crash, you will twist your body because this part will move more. And when you twist your body and at the same time have a compression, you will destroy your spine. It's just common sense, mechanics. This is the correct geometry. That's also a point that most people don't understand. As you can see in these seats, you see it's strapped straight through, like this. This is what we see in most cars. The lap belts, the belts between your legs, they go straight down to the anchor point. The whole idea with 6-point seat belts is to create something called a triangulation. In the early days we used 4-point, 3-point seat belts, then 4-point and then 5-point. And then we realized that if we had a side impact, or hit like that, this part of the body was moving in the side, and then we added 6 points. So the belts that goes in between the legs, under the legs like this, they should be triangulated. If they are triangulated like this, they will stop the hip from moving at the side. And if you then install the seat belts like this, down to the floor in a car, straight down like this, it will just be a 5-point seat belt. It will not help your body from not moving in the side. So 6 points should always be installed separate, 20 degrees at the side. That's how you install them. Lap belts, as I told you, this is the strongest part of the body. Here, this is the part where we try to remove as much energy as possible, because this part, these bones, as I say, doesn't break very easy. In a crash, what we aim for when we do the testing and the dummies and the development of seatbelt is to remove about 75% of the energy down here. If you touch your own body, you will feel you have something called a pelvis hook. It's a hard bone, it's like a hook here. That's where the lap belts should stop. They hook over here and they stop you from moving. If they are too high and go over this hook, you will slide in the seat. And when you slide in the seat, I will show you a picture of that later, you will break your back and probably your ribs and some of the vertebrae. Over the shoulders, this part, belts going through. Always, if you use a Hans device, you must have seatbelt geometry going down. 10, 20 degrees. Extremely important. Put this on. If you have this geometry incorrect, this is how a Hans device sits on your body. As you can see, it slopes down like that. It's covered in rubber. The rubber is there to create friction. The seat belts are against the rubber, and that's what stops your head from continuing at 150 kilometers per hour. So you hook this to the helmet. The seat belts are on here and keep this one stable. If you have this geometry wrong, so the seat belts comes from up like this, the Hans device needs to tilt, go all the way down here, and when you come down here in the crash, this part will go in and break your ribs. That is what happens. And on the other way, if you have this geometry incorrect, so it's too low, you will create too much pressure on the collarbones, and you will have a spine compression instead. So geometry of this harness over the shoulders, that's very important. And E over there, that shows a problem we have had with Hans devices. We own Hans also, so it's not talking shit about the product, but what we have learned over the years is that if you don't angle the belts together behind, like this, they might slide off. It's better to keep them angled together, because then you can avoid the belt sliding off. What we also have learned is that this type of seats, they are based on a homologation from 1999. They were homologated together with 5-point seat belts, and they are actually allowed to flex 185 millimeters. This much is in the specification allowed flexing. So if you take the seat belts together, 10, 20 degrees, you will stabilize the seat as well. And when you stabilize the seat, you will be faster, because you don't need to use your arms to stabilize the seat. It will be much easier to drive. And when we talk about harness geometry, this is from one page of the FIA rulebook, and then you turn a couple of pages, you will see that picture. And as you can see, it's very difficult to understand what they want us to do, because the information is, it will be the same body in the car, but the information is not exactly the same on both pictures. So I understand it is quite common that people install seatbelts incorrect, but for us that do development and testing, we always do it in a similar way, every test, and it's same for you. You must use and install seatbelts the correct way if you expect them to work together with your body. Here you can see this picture. Forward was something we used when we were doing 5-point seat belts. This picture over here, it says it's okay to have the from 0 to 45 degrees. That is actually the belts that goes through your bottom of your seat. If you put them backwards, like it say on the picture, they might tear up the bottom of the seat. In a crash, the belts will tear the seat apart. We have seen that several times. So the best recommendation as it is today is to go vertical down there, about 45 degrees here and 10 degrees behind your back. That is what is functioning, that is how we test seatbelts today. This is just to clarify. Short seatbelts, don't do 45 degrees behind your back. Most of the cars out there, they actually have 45 degree slopes in Europe. The reason for that is because we have a regulation based on something called supercars, touring car, supercar regulation. That's for rallying, it's for rallycross, etc., and also GT cars. That's an old regulation that was done 25 years ago, and it's still in the rule book, unfortunately. What we want is short seat belts, 10 degrees. That is what we want. If you want to be safe, you should always try to have it that way. This is just a picture that shows you how to lock seat belts. It's very common that we see seat belts, they are mounted, and this part is not locked correct. This is how we see it in many cars. When it looks like this, it's not locked. It should always be folded over. One more time. Here's a film showing me, I was at a historic rally. You know, historic rally cars are really expensive. And it was 85 cars that were in the rally, and 80 of the cars had the seat belts installed incorrect. It's amazing. It was $100,000 and $150,000 rally cars, Euro cars, and all of them, almost all of them, had the seat belts installed incorrect.
Wow.
And what I'm talking about now is not about buying more equipment. This is just using the equipment you have in a correct way. So then about seats and seat dimensions. The seat is as important as the harness actually, because they work together. But that is based on that you choose the seat correct. So you have a seat with the correct back length and width. The back length is the key to success, so to say. When you pick a seat or look for a seat, this is important. When you're seated in the seat, you have a Hans device on or a hybrid device. This belt should be in the center of the hole. That's where it should be. If it's riding like this, the Hans device won't work. If it's touching up here, you will have a spine compression in the crash, because the energy will force you down in the seat. It must be in the center of the hole. That's why the more recent developed seats have larger and larger holes here to fit more bodies. There you can just see how it will be. It will either slide, go through your ribs, and the energy from the head pulling over here, will go down here through the ribs and out through vertebra T6, 7 and 8. Will break your back. You will survive, but you will be actually damaged for a couple of months. And if you have the seat belts pulling too much down like that, you'll have a spine compression. Only because you have installed the seat belts incorrect. And this is how it looks when you have a draw. This part, the lower part, will slide in the seat. When you slide in the seat with this part, you will go lower. And when you go lower, the Hans will slide over. You will bend like this, and the back will crack. If you do it correct, it doesn't look much different, but this is with exactly the same equipment, but it's installed correct, the seat is chosen correct. The guy or the driver or navigator will survive, because this part is fixed. It stops first, then it stops the chest, and finally the head. That's a 1, 2, 3 step process. And this is what we strive for. On the left, you can see everything stops at the same time. The hip, the chest, and the head. the energy peak is very high and something will break in your body. To the left, no, to the right, here you see what happens if you stop the hip first, and then the chest, and then the head. So it's all about really, really tight in the car, correct harness geometry, and you will actually survive really, really hard crashes. Like in NASCAR, they've been studying this for so many years, and they have developed special seats and etc. that you can adjust in 5mm steps to fit the individual, and they know exactly how to remove energy. So we should learn from that, or we are actually learning from that. So this is about seatbelt. Doesn't matter how expensive seatbelts you have, how many anchor points it is. If you install them wrong, they won't save you. They will keep you in the car if you're lucky, but you will destroy your body. This is showing what happens when you do track days with 3-point seatbelts and a helmet. You will break your neck in a crash. And that's very common, that you buy a Porsche or some kind of sports car and you don't have 6-point seatbelts in it, and you go out there and do track days. You put 2 extra kilos on your head and you go off and you crash and you break your neck. It happens a couple of times a year. There is a solution for it. You can actually use a head and neck restraint today together with 3-point seatbelts. And that's a big, big difference in that crash compared to the first crash. So think about that. If you do track days and you do it in a class where you don't need to have roll cage or 6-point seatbelts, think about this. And there is head and neck restraints available for that kind of racing also. Seats, all seats the same? No, of course not. It's very strange. We have lifted this discussion lately actually, and I've written a couple of articles about it. Why people in drag racing, you see the left seat over there, it's the fastest sport, it's the most energy in the sport, and they use the baddest seats. They use crap seats. And we have a lot of back accidents, you know, they hurt themselves really bad in the back, or fired in drag racing. A good seat, this is okay seats, it's not good seat, but it's okay seats, according to me. But a good seat must have, first of all, side protection for the helmet. It's extremely important. A good seat also should have shoulder and support over here, so you stop the head, you stop this area. It should have high support over here, lap, side, so you can't move it at the side. But what it also should have is, in my opinion, a possibility to back mount it. This kind of seats, the most common FIA seats, they only mount in the floor, but the development looks like it will be more and more seats that have the possibility to, you can bolt them in the back as well. Because seats, when you're driving and the seat is flexing 10-15mm like this, you will be more and more tired because you're sitting there and holding the steering wheel in your arm. You're holding your body with the arms because the seat is flexing all the time. And when the seat flexes, the belts will be loose. Because sometimes it's flexed more like this, and then the belt will be loose there and slide off the Hans device. So what we want with a good seat is today 6 mounting points, side protection for the whole body, and correct size. It's not about buying a seat, it's about buying a seat that fits you. Very important. And if you go to some dealer and buy a seat or look at seats and they don't have exactly what fits you, ask them to find it, because it's always, measurements are available, they can measure you, put you in a seat, and then they see, okay, you are too short or too high, we need something that is higher. It might not be a Sparko seat, it might be an OMP seat instead, or Race Tech or whatever. But there is always seats available for all of us. But you need to research. And make sure you find a seat that fits you. Because it makes big difference in the crash. And this is how seats, this is the development of seats. We have similar seats as this in, it's actually a seat. It's a carbon fiber tub, And there you can see the slots for seat belts, and you actually anchor the seat belts in that seat. It's not anchored in the car. And in NASCAR we use similar seats. It's used in TTM, in V8 supercars in Australia. The plan was for the new WRC rally cars that were introduced this year, was to use this kind of seats, but they couldn't do it because the cars are too small. But the aim was to use similar seats like this. And in this case, you can also, they are splitted like that way and that way, so you can adjust the height of the seat in 5mm steps. And the reason we have this kind of seats is because it's needed. And they are not very expensive. They are as expensive as this kind of seat in the 8862 homologation. So it's not a very expensive seat, but you have to buy it first and then build your car. And that is something that I also tell people, that when you want to build a rally car, drift car, touring car, or whatever you build, the first thing you go, buy a seat. That's the first thing you do. You buy the seat that fits you. After that you build the car. Extremely important. And here you can see a little bit more about harness geometry. What we want is to have the lap belts as low as possible. We always talk about something called clean sight. If we look at a typical, this is actually quite good seats. They have the holes, the lap belt holes quite low. But some of the FIA approved seats, they have the lap belts up here, and you have to go through the hole and then down. That's not clean sight. We always want the seat belts to follow your body and then go straight down to the anchor point. They should not be pivoting on anything. Straight down to the anchor points. And here you can also see, this is a typical 5-point, and that is unfortunately exactly how many of the FIA approved seats look. They are actually built after the 5-point seatbelt standard. If you use 6-point seat belts or 7-point seat belts, it should actually be, the holes should be back here, or like it is in this seat, 2 holes, 2 slots that make the seat belts go in the correct direction to the anchor points. But it's difficult to find that kind of seat. This is something we developed with FIA, I think it was 5-6 years ago. And it's been introduced in Europe. It's been used in World Touring Car, in GT3 cars now. It's something called driver's net. It's a net that most of the teams, they install them incorrect. But if you install them correct, you take them like this, behind the seat, and that one anchors to the main hoop over there. And the belts coming from that side goes around the seat and anchors over here. Which means you create the cage. Very, very safe cage for yourself in the car. And it's not very expensive, it's cheap actually. So you can use this kind of seat. The cheaper seats, you use the nets instead to keep you stable in the car. Very good solution. It will also stabilize the seat. This is how it looks when you crash with that kind of net. This is exactly the same crash as I showed you in the beginning. And that film showed someone that was hitting, he was always all over here with the head. And that guy stopped about here. This guy survives. And it's an extra cost of, I think it's, I don't know, 100 euros or something? Lower, okay, so it's very, very cheap extra protection. And this is what we're talking about, keeping the spine in line. If we use 5-point seat belts, we use this kind of seat, open seat as I call them, and we are not correct in the geometry here down with the lap belt area. The body is fixed up here, and this part of the body will go at the side in a crash. And when you are like this in a crash, and then you have a compression, you will break your spine. That is what happens. The goal with the seats, with the seat belts and the correct geometry is to create this, to keep the spine in line. And as you can see here, it's a straight. You keep it straight. That's what we want. So when you're in your car and you sit there strapped in and you feel, oh, I can move, then something is wrong. It's the same with seat belts. If you go out, do a lap, and then you retighten, and then you do a lap more, and then you retighten again, something is wrong. It's not your body that's shrinking. It's the belts that are giving, or you're sliding in the seat. Most common is that you're sliding down in the seat, and when you slide down in the seat like this, and you tighten, 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 and then you crash, you will break your back. That is what happens. So whenever you use a seat belt, and you realize that, shit, I'm retightening every second lap, something is wrong. It might be the seat belt as well. Some of the seat belts are really bad, so they slide in the lockers, lock mechanism, they slide. It might be the, where is it here? This part that is installed incorrect, so it slides, so it can be a couple of things, but one thing is for sure, if you have to re-strap several times, something is wrong. It's dead wrong. And this is just to give you a picture of, go back. This is the spine. Between all vertebrae, every number here is connected to a function and a feeling in the body. So if you break T6, 7 or 8 in your back, if something happens there, I know for sure what will happen with your fingers, how the arm will react, and you might heal for 10 years or something when you're young, but when you get older, the problems will come back. It's always like that. So what you must do is to protect your spine, and the best way to do it is seat belt, correct geometry. Then about cars, when we started to build motorsport cars, so to say, we put a cage in them to be safer, because when they roll, they get flat and people are killed. What we do now is sometimes we actually build cars with cage to make them faster, which is a big problem, because the main idea behind the cage is to make it safer for the occupants, the people inside the car. I think this is a good example. This was the WRC, the Mini Cooper, when they decided to build that one. They actually, the bars over here, they were moved out in the door, and they were not allowed to do it. So that's why it's not a Mini, that's why it's a John Cooper Mini Works car. They had to re-homologate it, and they removed the B-pillar from the car and put in a B-pillar that is like this. It's a totally separate homologation of car. It's not a Mini Cooper, it's a John Cooper Mini Works car. And they did that because they wanted the bar that is on the side like this to be as far away from the driver and the navigator as possible. And that is to be able to absorb energy in a crash. This is also a good example how to build cars. Short seat belts. And in this case, a rally car. So of course the navigator is lower. So what do? Yeah, you put the bar where the seat is. You don't put the bar at the same level and then try to make something work out. You make it for the driver and for the navigator. And as you can see here, they don't use the bar that goes here. They added extra bars in the car just to make sure they are safe. Not only to make a fast car. It wasn't particularly fast, but it was a great idea. But this is how they look. All the modern WRC cars, the modern GT3 cars, they look about this. They have short seat belts, they have individual height, which is the key to success if you're two in the car. And that's a problem if you do GT3 racing where you have driver changes, for example, do 24 hours. If you have very different length, if you have one driver that is 165 and one driver that is 195, it's a big challenge to make that work. And we have no solution for it. This is a typical error in our mind. This is a roll cage that is there, a bar that is there to, we call it helmet crusher bar. In this case, Marcus was using, this is a rallycross car. He weren't allowed to use his own seat, so we have a too small seat. The whole idea with the seats is to have this point in the center of the eye line. So when you do scrutinizing, this should actually be in the center of eye line. And if the scrutinizer, the tech people see that you are too tall, you can look over it, they can actually tell you, no, you can't use that seat. So that's one of the things to look for. But he's, as you can see, he's too tall. So what happened, he jumped and something broke in the car. And the car went to that direction, to a concrete pole. He hit it really hard, and then the car continued that way, and his head went that way. His head went directly into that bar. And you can see a small piece of padding there. The padding was so close to his helmet, so one of the car engineers was kind enough to turn it outside. He moved the padding from the helmet direction to the outside, so he actually crashed with the helmet, broke the helmet against the bar, and was unconscious for 4 days. And he's not okay yet. The reason for the reason this happened was, of course, something broke in the car and hit something hard. But as you can understand, the safety products weren't used correct. It was wrong seat, no padding on the bar, and what we see talking about bars is this is actually talking about bars. In modern cars today, you never put a bar like that. Today you don't put a long bar at the side of your head, you make a short bar and you curve it and you box it. This is a typical car with a window net, and as you can see, the seat belts are installed incorrect. They are locked over here, they should be locked over there. The geometry is wrong. If you use a window net, the window net should be about here. It should go so it covers your arm. If it doesn't cover your arm and you roll, things will happen. And that picture shows how it looked when you roll and the door is turned away and you slide out with your arm and the car is rolling. When you then remove the gloves, the fingers will still be inside the gloves. Think about that. Totally unnecessary. Make sure you use the window nets correct. It's just a small detail. Next step is to talk about suits, racing wear. And here we have a typical racer with a suit. The suit consists of different materials. You can have soft, you can have shiny, you can have different type of materials. It can be 2-layer or 3-layer. So if you buy a 3-layer racing suit or a 2-layer racing suit, it doesn't matter. It's the same protection. The thing is that the more layer you use, you can use thinner materials. So it's more flexible, it gives better comfort, and it's more expensive. The whole idea with the racing suits are to protect you from fire for 9.5 seconds. It is about the time it takes for you to start to think about if it's burning. So it's only 9.5 seconds to second-degree burn. So when we test them and develop them, we put them on a burner, 9.5 seconds, then it creates 980 degrees on the other side of the fabric. And 980 degrees Celsius is about when you start to get second-degree burn damage. So think about that, 9.5 seconds, and that is when the suit is clean, it's dry, and it's in perfect condition. The layers in a suit, if you have a 3-layer suit, we have the outer shell, and then we have air, and then we have the middle shell, and then we have the inner shell. The whole idea is when it starts to burn, it starts to be exposed for fire, it will swell. So it stops the heat from transferring. And then it has to go through the air to the next layer, and then that will swell, and then through next air layer, and then it will burn you. So that's the idea behind racing suit. And then you understand that if you use a racing suit that is oily, dirty, or wet, it won't work the way it's designed to work. The heat transfer will be instant. We have racers where we actually, when they use patches like this and put them on, sponsor patches, and they use a patch with glue, wrong type of glue, when they are burned, the burn mark will show the logotype. So that's called heat transfer. So make sure that the racing suit, first of all, it should not be too tight. If it's too tight, it will not be air enough to stop the heat transfer. It must be clean, and you should also inspect the suit for, up here you have stretch materials. Sometimes the stretch materials break. Check that at least a couple of times a season. And make sure you also clean your suit, because if it's dirty, oily or whatever, you know, in some racing series, if you use your racing suit working on the car, you're disqualified. Instantly disqualified. And there's a reason for that, of course. Correct size important, keep it clean. It is, on the market you will find special cleaning chemicals you can actually wash them at home. You don't need to send them to the cleaning store, you can do it at home. More about that? Underwear, of course, FIA homologated underwear, the price range is from, let us say, 50 euro to 100 euro, and it is different functions, and they will protect in different times against fire. And you can consider the underwear to protect you maybe, in general, 1 second more. So it's very limited. But the good thing with underwear is that it's easier to clean the underwear than cleaning the suit. So that's a good thing. And there is some underwear that you can use that actually create cooling. It cools you off, a cool feeling. There is underwear made of something called carbon X that actually stands more time against fire than the racing suit do. And it's really thin. So it's different materials on the market depending on what kind of motorsport you're doing. In particular in drag racing they use something called carbon X. It stands 19 seconds against burn through. And that's just the underwear. But in drag racing we have a different problem, that is poisonous gases. I will show you some pictures later of people are exposed 50, 60 seconds for fire. You can't breathe them, so you use breathing systems in the cars. Just a note about this helmet. I'm not sure about your regulations, but in some countries it's okay to use motorcycle helmets in the rulebook. And you're forced to use racing shoes, racing gloves and racing suit, but you can still use motorcycle helmets. This is a typical motorcycle helmet. It took 2 seconds for the helmet to start burning. We did the test. Put the torch over here like how it is in the car when the car starts to burn. From below here, we had the shield slightly open. 2 seconds it started to burn. It was almost impossible to take out the fire. And what happens with this kind of shield is that it melts, it drips inside your helmet and under your racing suit. This driver would have been perfectly fine because he was using racing suit, racing gloves and racing shoes, but the eyes, the nose and the face would have been destroyed just because he was just reading the rule book, and the rule book said you can use motorcycle helmet. I'm not sure if you can do it, but it's only you that know.
From this moment now.
Okay, so you have been, it's been possible. Okay. Yeah, and this is the piece you use to attach it to your body. This is not funny at all. This is a fire. This guy survived. But the reason I'm showing the picture, I know him quite well. He burnt off his fingers and nose and a lot of shit. But he's okay and he will race again. But I show this picture because to the right, so what do you do when you have a fire in your car? Do you know how to get out of the car? Yes, you know how to get in and get out. But when it's filled with smoke, when it's upside down, or maybe you're parked against the wall like this and you have to get out on the passenger side. Have you tried that? That is something you always should do blindfolded. Don't do it with your eyes open. Put a tape over the shield. Make sure you can unstrap without seeing anything. Get out of the car, you know. And if you have bars or shit in the way, you must learn how to remove that so you can get out. Because the first part of this, my part of this seminar was to talk about how to keep you safe. And that is quite uncomplicated, just common sense. But when we start to talk about fire, then it's really difficult. Because all fires are different. And you must train and learn how to get out of your car. He was exposed 52 seconds for fire. If we'd been using that kind of suit, he would have been dead. He was using something called SFI-20 suit, and that is a suit that is built to withstand more than 45 seconds, 1,000 degrees. He was using a helmet with a skirt going in under the suit, and he was using a breathing system. He used diver air, fresh air connected to the helmet to make sure they don't breathe poisonous gases. So that's what we're using in the top level drag racing classes. But think about it, if you go 250 kilometers per hour and you get fire in the car, how long will it take for you to stop the car? It's more than 9.5 seconds. This is one of the last pictures that is something I think is extremely important. You see the pro are doing that, but most people are not. That is track walk. Every time you come to a track, race track, walk the track or take the bicycle or whatever, for you don't have a clue what people have done on the track since you were there last time. They may have changed something. If you have the gravel, maybe they have forgotten to make it soft. It's hard as a rock. We had one race, they actually, something in Sweden, they use something called leka balls. It's a soft material to stop the car. The owner of the track had forgotten to soften it because you have to go to the retractor and move it and put air in it. So when the car hit it, it took off like that. And it was flying for maybe 40-50 meters and stopped in a barrier. And that's, just make sure you walk the track, check the track so you know exit points, so you understand where the safety people are, where the fire crew is. Very important. It's just common sense, take care of yourself. That's what you do then. And if you have a car that is maybe different to exit, or a car that some way is strange, ask the safety crew to come and look at your car. Ask the fire crew to come and look at your car so they understand your car. They will remember, and they will be really happy to see the car and that you teach them and tell them what they should look for if you have a crash. This is also something that we see quite often in the factory where we make the helmets. To the left you will see that's the inner liner inside the helmet, and it's melted away. That's mainly because the painter forgot to close out the ventilation holes in the helmet when they paint them. We paint them in the factory, but when we paint them we have no interior in the helmet and we just paint them. But when you do it at the paint shop, the interior is there, everything, and if you don't close out the ventilation holes, the helmet will be destroyed. So make sure your painter, if you paint your helmets, that they understand this, because a helmet without energy absorbing material will not help. This is my final picture, and this is what it's all about. It doesn't matter how good equipment you have, if something is installed incorrect, you will hurt yourself. Okay, thank you.
Cool.